All right. Good evening, graduate UNSY and research students. First, for everyone's awareness, we're going to be recording this session, and a copy will be made available for those who are unable to attend live. Next, for the format of tonight's meeting, I'm going to start by introducing our guest, who will describe his connection to the unmanned system technology field. Afterwards, I'm going to lead a series of introductory questions, after which we're then going to open up to a class-wide Q&A session. I do ask that you mute your mics and save all your questions to the end, and that you use the hand raise icon to indicate when you do have a question. I'll try to call on each of you in order. I also want to note that I'm going to be capturing and sharing online links to important concepts, details, and tools that are brought up in our discussion. I'll try to send those out in an email announcement tomorrow morning, along with a recording of this meeting. So with that, I am really excited to welcome you to the 19th session of the UNSY Guest SME Speaker Series. This is the first of 3 for this term. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Unmanned Systems degree. Tonight, we are joined by our guest subject matter expert, Michael Miranda, the Director of Flight Operations at HoverFly Technologies. His role in the SUAS industry has been an ever-evolving journey, which stemmed from an early age and interest in recreational remote control planes. He's been building, piloting, and innovating within the RC field since high school and continues to pursue his passion outside of school. Michael has built several unmanned systems as a hobby and eventually found his way to Embry-Riddle, where he completed the Bachelor of Science in UAS Science degree at our Daytona campus. Starting out at HoverFly, he's used all the skills developed in pursuit of his hobby and education to solve problems and contribute to engineering designs. Working his way from a novice flight operations specialist into building the entire flight operations department from the ground up. Currently, the department has 13 people from flight operations specialist to chief pilot, and all in between, with over 7,000 documented flight entries spanning 20,000 plus landings, thousands of hours of flight time. Mr. Miranda has traveled for HoverFly on over 100 business trips all over the world, from South America, Europe, Africa, and all of North America. He's helped members of various Special Operation Forces communities and has been privileged to participate in countless robotic events and exercises for the Department of Defense. With that, I would like to turn the stage over to Michael to tell us about HoverFly Technologies, as well as his experience and observations associated with this rapidly changing technology.
Hello, good evening, everybody. Thank you, Brent. I am Michael Miranda here, as he introduced, and really happy to be here and get to talk to some students that are going through the Unmanned Systems course right now. And I feel like this course had a large impact on my career and my ability to get to the point where I am now. And it really opened up a lot of doors and brought a lot of knowledge into the field of UAS that I now work in. As I understand it here, yeah, I apologize for that. My camera here is just kind of broken. It might come on in a few minutes. I'll keep giving it a try. So if you can still hear me, I'll keep going until it shows up. So as Ben was introducing, I started working with UAS quite a long time ago as a hobby. It was just a fun thing to do. I never thought it would be a job that I could get in the future. And some of you may be going down the same path. But I have come to find, amid some speculation and turmoil, that the UAS industry is actually quite lucrative and very much on the growing phases of its life. I know there's all this idea of, you can go out and get a job, but what are those jobs? How do I get those jobs? And really, what are people looking for? These are the questions I had in my mind when I was going to school for this kind of thing. And I kind of want to bring some of the things I've learned over time to you guys and really emphasize what I think are important skills and what I think have made a difference in my career so far. And hopefully it's beneficial to you. I have a little bit of a presentation. If you guys are okay with that, I will share it with you. So just to kind of give you guys a little bit of background of what we go through and what I've gone through with HoverFly so far, just starting from the top, HoverFly is a tethered UAS company, a manufacturer. So what we do is we engineer, we design, we test, and we build tethered drones. They're all tethered, they always stay tethered, and there's no way around that. Part of why HoverFly got into that was really because back in the day when HoverFly was just starting out, they were making flight control boards. And eventually this little company cropped up, you may have heard of them, called DJI, and they started making flight control boards. Well, DJI has a lot more manpower and money to grow rapidly. So HoverFly had to quickly shift gears. They moved on to this concept behind tethered drones. No one was really thinking about this back in 2013, 2010. So they started to build out these concepts and eventually had some prototypes. And one of the things that I've learned, just a quick note, is the education process, the convincing the customer the why, the what for. It takes some time. It's not as easy as, hey, we'll just show them and they'll spend a bunch of money. You really have to kind of walk them through the whole process, show them the benefit to their current situation, and then help them out in implementing. Because at the end of the day, you're supposed to be the subject matter expert, and the customer really just needs to know how to make the most use of this equipment. So HoverFly moved on to that and started iterating, eventually ended up with a very well-oiled, repeatable product that's quite reliable. So you're able to sustain flight at max altitude of 200 feet for periods of time as long as you have power on the ground. So we've done easily 48-hour flights. We've done 3-month bench tests where it's just running out there going. No one really wants to babysit it for 3 months. So we do that kind of thing on the ground, but long duration flights are not an issue. Whereas with a battery powered drone, you have a lot of limitations on that front. So just a little overview about the flight operations department. This is probably the area that I see a lot of UAS students going into. And really it encompasses several things. You really got to be able to conduct flight testing in an efficient way, but really being focused mainly on the data. You're not necessarily focusing on the ability to fly an aircraft or the the piloting skills or anything like that. It's more about, how do I analyze the data? How do I interpret this? How do I identify problems before they get past me? And really, a lot of times it's subtle. It's not as obvious as you might expect. So getting proficient in identifying, reading logs, identifying key parameters, knowing what to look for, and really just being ready to learn, I think is important. Next, training. As a subject matter expert, you're going to be the person that goes out there and trains somebody else. So you need to be able to effectively communicate the things you've learned and the things you know about the aircraft so that the operator can make the best use of it. Demonstrations comes right behind it. As it, when you're getting into this industry, and I've seen it in many companies, you have to go showcase the technology. No one's just going to get it by an email. So at the end of the day, before anyone buys anything, you're going to go out there and you're going to fly it in front of them, and they're going to ask a bunch of questions. They're going to want to see things that you weren't prepared to show them. And you need to know how to navigate the waters, and not just with communication verbally to sometimes very high level customers, but also to be able to effectively handle the technology behind it as well, the technical side. Customer support just kind of falls under the blanket of, as the SME, you tend to know the most about it. So you can help you can help people the easiest. And then for me in particular, I focus a lot as well on FAA waivers and different legal aspects of the flight operations department. So just talking briefly about the picture you're seeing here on the screen, this is an example of an unexpected situation during a training. This training took place in the Netherlands, over in Europe. They had purchased some systems for the Ministry of Defense, and we get there, we show up, everyone's expecting one thing, and then all of a sudden they have this unmanned ground robot, and they want to strap this thing to the top and see how it, see if we can fly off of that. Now, completely unexpected. You're in a foreign country, you're on your own, and you only have the gear you plan to bring. How do you handle this? So these are the type of situations that I see encountered all the time, and really should be expected at this point. In this case, everything worked out great, right? We thought it out. We figured, hey, what's the best spot to get the aircraft away from any magnetic interference or compass anomalies that we could potentially avoid? So we mounted it very high. Okay, how are we going to hold it down? Ratchet straps is always a good option, a little better than duct tape. Then, all right, well, let's make sure we have a safe area to fly, no obstructions. You can see surrounding areas, just dirt and nothing really in the way. And you take baby steps. And eventually, yeah, it worked out really great. They were able to drive this ground robot, and the tethered drone has a follow capability. So you're able to have a tower at 200 feet with either camera or radio payloads that you can now make mobile and completely unmanned. For example, the radio that controls the ground robot could have been mounted to the drone in the air. So now you have clear line of sight from miles away, and you can control this robot without ever having to leave your bunker or anything like that. So these are the kind of experiments that people just think up, and you may have to adjust on the fly. Jumping into what flight testing looks like. Really, I think this is, this is what it is at HoverFly, but now it's probably similar across the industry. Is just there's production testing, right? You have to qualify the final product. You have to make sure the drone is ready to ship. And that is a series of standardized test plans, standard flight logging. You enter the same data. It's a lot of data entry. You want to make sure you capture all the metrics, weather, wind, how was the landing performance, where are the logs, what can you say about what you noticed on landing, just little things that may not mean anything right now, but 6 months down the line when someone has a problem, that flight log could hold the answer. You just never really know. So I created this method for cataloging and documenting all these flights and date and different hours and stuff. And it's a great tool for the guys to not only keep track of their stuff, but keep track of their hours as well. It doubles as kind of a logbook for the pilots. Down here in this photo, you're able to see another example of a kind of a robotic integration. Up here in this little corner here is what we would call the tether kit. That's what houses the internals of the system. We have power conversion, we have all of it's on an Ethernet network-based system. Everything has an IP address, right? Easy to integrate with. You can connect it to any computer, and it converts, 120 AC or really 90 to 260 out to 400 volts DC up that tether, and then we downstep it at the aircraft to a 26 volts DC. So all those little details about the power communications come into play, especially when you're talking about large vehicles like this. You need to have the right power source, the right networking, and all this. And this, just for example, I mean, this thing is like 12 feet tall. It's huge, and it's a Bradley. And so they mount it to the top, and basically they use it as a periscope. You're able to go behind some woods, behind a hill, for example. You have a very large vehicle, very obvious. But if you launch this tiny little drone over the tree line, and I can look 2, 3, 4 miles out and identify, let's say, friend or foe before ever making the vehicle's presence known, that's very advantageous. Essentially a periscope in this case. So jumping down a little bit to training. So as was mentioned earlier, the pilots go out and they do all the training really, because as the SMEs, they're the ones most capable to handle that. So when they actually go on a training, it typically involves a customer's purchase system. They're fairly aware of what they're getting, and they really just need to learn how to use it. You're going to get all kinds of people, from total experts who probably will outsmart you, to people that, couldn't put a circle in a circle hole. It's going to go both ways. So you got to adjust your communication skills to the person you're talking to, be able to relate it to something that makes sense to them, but also be able to ensure that they got the key information. In our case, that really is emergency procedures. We want to make sure that they know what to do when things go wrong. The system itself is extremely easy to use. It's basically an elevator. You just hit up or down. It sounds, it's really boring actually once you get it going. But at the end of the day, the customer is going to get complacent. They don't understand that they need to constantly stay aware or be expecting the unexpected, whereas someone who's doing this day in, day out has seen all the problems that could potentially happen. They're going to be a little bit more on edge and heightened and ready to react in case the emergency procedures need to get used. And this, once again, this is a photo of flying a system off of a boat. So we're able to do maritime applications where you can follow the boat, drive up and down riverine or oceans, and be able to use the camera for long distance viewing or a radio for transmitting data back and forth to shore. It kind of bridged, one of the experiments we did kind of bridged like a naval carrier fleet was simulated out in the ocean to a land-based headquarters, right? Our boat was in the middle and we were able to bridge that with a radio. Very specific kind of radio, but radio nonetheless. So this picture is actually a little bit outdated. There should be more dots, but another thing we do is demonstrations. So CONUS and OCONUS, whether it's in the US or outside, really got to be able to support customers around the world. Now there's some extra dots here that should be in South America, Africa, and growing even. I don't know if this may not fall into everybody's role, but for me particularly, I was really excited about traveling. And now I don't know anymore. There has been way too much travel. I'm actually on a trip right now that I wasn't expecting to be on. So that's probably part of why my camera's not working. So anyways, being flexible, being able to go these places on your own, being able to kind of handle the situation that gets thrown at you is a key skill I think that most people in this industry should understand. You're going to go on your own and you're going to have to deal with something that you didn't expect. That's just the name of the game at this point. But being able to show up at an event, communicate effectively in front of a large crowd, and really showcase what you're doing in a concise manner, I think is very important. And then also you handle all the equipment of the operation and the public speaking. And it's really up to you to make sure it's all going to work. Ahead of time, you're going to know some details, but your boss or your manager may not know to ask the right questions. Hey, do we have clearance to fly here? Hey, are we in the right airspace? Look, are there going to be people around? Should I be aware of that? These are the kind of things that you need to start planning ahead and be aware of, that it's going to fall on your shoulders at the end of the day. So, and then jumping down briefly to customer support, this ideally will be broken up into a separate department, but a lot of times people will rely on you for your expertise. So if you can imagine, the engineers are in their little pigeonhole where they're seeing inventor all day and they're putting their things together. The electrical guys are in Eagle or some other program where they're just making circuit cards and doing all that. And they're all very aware of what the system's capable of, but they don't operate it every day. They don't see what happens after the fact that they create it. And then it all culminates in the flight operations area of the company. So all of that work and effort that got put into it in the labs and by the technicians and all these other people really comes to a head when it has to you have to hit the launch button. That's kind of what it all comes down to. And as SMEs or working in flight ops, it's important to have at least some good knowledge of all those various areas. I'm not an electrical engineer, but I can speak to the electrical circuitry in the system. Same as I'm not a mechanical engineer, but I understand the mechanical design behind what we're doing. So being able to kind of bridge the gap between engineering and the customer, I think is important, because a lot of times you put an engineer in front of a customer and they're going to say stuff that just goes way over their head. And it doesn't need to be that hard. You can simplify it down in a digestible way for the customer to really grasp what you're trying to say. And, sometimes that means troubleshooting. It really does. You're going to get a problem and no one's ever seen it before, and you're going to have to try to figure it out. So being able to get a little bit methodical about how you solve things, and kind of understanding, well, if I have a really great understanding of the circuit, now I can understand, oh, if this part's not working well, it relies on this other part right here. And then you can start to narrow down where to troubleshoot, where to aim, and kind of where to find the problem. In these photos here, you probably recognize the top building. I don't know if I even need to say it, but I'll give you a hint, it's in DC. So we, just story behind that. I mean, out there one day, just doing our thing, and get a call, and customer needs support. There's something going on and they want to have a drone. So we help them out, we get it to them, and they had an issue, of course, unexpected. And we were already in the area, kind of anticipating if there was any problems. And we were able to go out there, put it together, and I was able to launch the drone successfully and get it back in operation for these guys. That's, for me, a very proud moment, because that's a TFR, if I ever saw one. And just being able to say you got to fly a drone there is something very unique that I think was exciting. And then in the bottom picture, you're seeing multiple drones. This was actually during a long duration test for the Army. Had to do a 48-hour flight with 3 different systems on 3 different power sources, all side by side. That's a lot of manpower, a lot of people to watch, a lot of people that need some sleep, and it's a tricky situation, and you got to plan for all these different things. So moving on a little bit to waivers and FAA, right? So I was fortunate enough to work with the FAA on multiple waivers and multiple different issues, and come to find that there's a really great team behind the UAS side of the FAA. I think that while it's probably not as big of a team as we would all want it to be, but it is a very effective team, and I think they're really great guys to get to know and answer a lot of questions that we have. At least for me, it's been helpful. I've worked with them to secure multiple systems waivers for both of our flight locations that we operate from. We can now fly up to 10 systems with 2 people at each location, and that's really it provides a force multiplier to potential production testing and being able to qualify more systems. It's great for the numbers guys. And then we also have beyond visual line of sight waiver, so anyone in the continental United States can operate our systems either at our HQ or in our Missouri facility, which is our production facility. So securing those waivers, it's not an easy thing. It took some time, a lot of communication, lessons learned, but it was a great learning experience. And I think it's really, it's a good thing to know how to do. A lot of people may be intimidated by it, I'm not sure, but I think just it never hurts to give it a shot, and then you'll learn from there. And then this is just this was a photo of us actually doing our first multiple systems flight, and you can see all the aircraft in the air there. That was fun. So another one here is just kind of the future of where we're taking things, more R&D testing, being able to work directly with engineers in a way that they get what they need, but you also understand what they're doing, and work together as a team. And then trying to standardize things as much as possible, really get it to rinse and a repeat level, and then continue from there. And you're seeing here is a Stryker vehicle with another system mounted on top of it. Once again, you can see the straps. I mean, it's always ratchet straps with these guys. So, you can just expect that they're going to want to put it on top of something. And in this case, it all worked out really great. It was a really good use of the vehicle. So I think that was the bulk of the presentation that I had. I, still can't get this darn camera to work, but kind of open the floor to, Brent, and, see where you want to take it from here.
So I'll start us off, and then if anybody else has any questions, don't hesitate to raise your hand on that. So leading off, what tools or resources do you use to stay informed with all the changing dynamics that are occurring? And follow up to that, what are some of the challenges of sifting through all the available material that's out there?
Great question. Well, LinkedIn is a great tool. Just kind of keep a tab open somewhere so you can always scroll around and see some new stuff. I always have the FAA's website open, ready to go. I check it, I have a reminder to check it all the time, make sure there's no new updates coming out. And usually when there are new updates, I spend a lot of time reading into it because I have to be the guy that's informed. So in terms of tools, I'd say those are kind of my primary tools, and then word of mouth. You deal with a lot of people in the same industry. A lot of people know a lot of things. Just keeping a good rapport with various others, and then it's not always on your shoulders.
What was that first tool? Was that LinkedIn?
I use LinkedIn. We follow all the drone things, and then you'll always see what's the latest and greatest.
Excellent. What are some of the pressing technological problems that you're seeing in the UAS field that could use more attention, could use further, maybe examination, research, educational development, you name it?
Okay, yeah. So I know one of the things that's plaguing the free flyer world right now is this idea of detect and avoid. So that's kind of the hot button for UAS. But in my particular world, that's not a very big issue. With tethered drones, they're stationary and they constantly stay in one place. So some of the problems that I've been seeing is really the limitations of integration capabilities. So I have a system, a drone, that I want to operate. I can fly it up to 200 feet and stay in one place, and I can fly a radio, which is great. But I want to control a robotic dog with a radio. So why don't I stick that radio on this drone, and now I can fly the dog. I can drive this dog from a tower, and I get extended range. Well, what if I want to run AI on that video feed and be able to detect and identify people and objects, right? So those are three completely different systems that you want to tie together all at once. It takes a lot of bandwidth, a lot of power, a lot of energy, but the tools are all available. So one of the biggest problems I see is the ability to integrate various technologies effectively and easily.
Okay. And then my final question before I open it up to the floor is, what specific guidance do you have for those students looking to enter the field, especially knowing you came from the Embry-Riddle environment, you came from UAS? What are some of the specific knowledge, skills, and abilities that you see helping support versatility and employability?
Okay, that's a great question, because as a person who hires directly people, I have gone through many interviews, and one of the key things that I look for is someone who is capable, willing, and ready to learn. I like, one of the things I look for a lot is just someone who can pick it up, someone who's got that energy to be motivated, be ready to go, and kind of ready to take whatever's thrown at them. Another thing that I think is useful as a more practical skill is getting hands-on experience with, being able to fly. I may be biased here, but I think RC is a great way in. If you go out there, how does the RC plane work? What, servos go to the receiver, you got a flight controller, potentially brushless motor, ESCs, get familiar with the inner workings of a UAS and what are the parts and pieces and how do they typically work. And then aside from all that, just being a person who, if you want to separate yourself from kind of the rest, what I've seen a lot is, I see a lot of these people that have DJIs and they go out and they'll fly, let's say for roof inspection, and that's perfect. I think that's a great thing to have. What I want to say is take it one step further. Maybe you've diagnosed some logs from your DJI drone. Maybe you've taken it apart one time and you know what it looks like on the inside. Even just hearing that, I would immediately perk up and be like, wow, this guy is curious. This girl has interest in what's going on the inside, not necessarily just the camera feed. And then, yeah, trying to understand how that all works. I think if you communicate that in the interview, it'll go a long way.
Outstanding. So now I'm going to open it up. We've got Chris. Dan, do you still have a question? I know you were having some hand raised. Okay, so it'll be Chris, Dan, Stephen, and then I know Mike had asked a question in the chat. I've got a clarifying remark out to him. So we'll start with Chris.
Good evening, everyone. I hope you can hear me okay.
Yep.
Looking great. It's more of a technical question. Just it sounds like a fascinating system, but the tether is what I guess piques my interest, and then the follow function. Obviously, you're flowing power through the tether, but is there any other control signals? And the specific question about the follow is that based upon a GPS between like the base unit and the aircraft itself? Is that how it's adjusting? Because it doesn't seem, from what I saw from the control pictures, that you guys have any like left to right control or anything like that.
Okay. Yeah, so just to touch on your first question, the power goes up the tether, but also the data. So we get the 400 volts, we overlay our data feed onto that, and then we send it up to the aircraft where we split the two streams again, downstep the power on one end, and then run the data through a network on the others. So yeah, it's all hardwired connection. You just need an Ethernet cable, and there's no RF emissions other than the motors and ESCs, but no signals. So then with the other question you had, can you just jog my memory one more time?
So I guess I'm curious, the follow function. I assume that like the GPS in the aircraft is being compared to the GPS in the base unit. Is that how it's making these corrections?
Yeah, that's the primary and safest way that we use it. We've also, if you can imagine where the tether attaches to the aircraft, there's got to be a connector there. We gimbalize that connector so it has movement in all directions, and we put an IMU on that, so we're able to identify the pitch and roll of that connector. So if you can imagine, I move the tether forward, then the aircraft's going to understand that IMU is moving. I need to adjust. We use that functionality for more kind of R&D type testing for landing on the move or launching on the move.
Okay. One last question, and I'll pass it off. But as far as like the industry as a whole, and you were talking about people with interest, I've done some DIY building myself, and done some programming with Pixhawk and so on. I mean, is there a niche for that, or is there? I guess is there? Go ahead.
Sorry, please finish.
No, I mean, is there a niche for that, or is there a market?
100%.
Custom built systems that you see?
Yes. I don't necessarily see a need, in my experience in the defense area that I'm in. I haven't seen a need for a custom system to be brought to someone. There are always going to be customizations, but a person with the skill to do that is highly valuable. So, knowing how to do that on your own, and you just said Pixhawk and being able to program Pixhawk piqued my interest right away. So immediately I'd have a bunch of questions for you. That kind of thing is a great differentiator.
Thank you. Thank you for your time.
Mm-hmm.
Next, Dan, and then we'll go to Chris.
Okay, can you guys hear me?
Yep.
Okay, cool. Hey, I had a couple of questions, and then I wanted to get into what you were talking about. The thing is, you said your production flight test is in STL. That's St. Louis.
Yes, sir.
Okay, it's interesting because I'm originally from Southern Illinois, near
Okay.
Belleville.
Yeah, if you know of Wright City, Missouri, then that's
Yeah.
the facility's at.
Okay. Another question. You said troubleshooting in the field and stuff like that. Being retired Air Force, we had to do. I was a part of a tactical team for the comm systems and stuff, and we didn't really have the luxury, like you said, we didn't have the luxury. We had to be self-sufficient and very qualified in our communications and IT stuff. That's my background, IT and telecom.
Perfect.
And but I was curious though. Once in a while, we did take a BGAN system out in case we had something really we needed. We would call back to the maintenance facility and talk with the guys there. Have you guys ever do that? Or
Yeah, absolutely. So you try to be as self-sufficient as you can. You prepare for the worst, but you do a lot of times rely on expertise of others back home, and that's a big deal, right? You can only know so much about one thing, but you want to call the guy who wrote the software when you have a problem with the software.
Yeah.
You don't want to write the code on the spot.
Yeah, no. Like I said, you do not have the luxury in the field to be done with that.
Right. It's tricky. And one of the things I do with my team is really, you got to get their feet wet. It takes time to learn. I don't expect anyone to know anything coming in, just be teachable. But eventually you send that guy out with the expert, and eventually he sees enough problems that he kind of knows how to solve them. And then, you go from there and try to build the team's knowledge and foundation is kind of how I approach it. Yeah, and I'll just say real quick, this network and IT background, that's probably the second most useful thing that I could think of in this industry.
Yeah, when I'm coming up through this stuff, I wanted to be, some people go through one. My associate's in electronics. My BA is in, our BS is in IT, and in this, I wanted it to be very diversified, and I learned that in the military. I had a supervisor who said, "Look, you want to learn a lot of stuff across the board," and that came in handy. So
yeah, great skills to have.
Yeah, and so like I said, I got an IT and telecom background, so this is a career change for me. But what you were saying earlier is, I was kind of laughing. I was like, man, this stuff is, for what you were talking about, it's you got flight ops and you got maintenance and builders and testers. And I'm like, man, this stuff is right up my alley. I was like, cool. Okay, that's all I had. I'll pass it on to you. Thank you very much.
No problem.
Thanks, Dan. Next up, we have Chris Lip.
I already asked my questions, Dr. T. I was the first one.
Oh,
I think it's Steven now.
Oh,
Steven Stern.
Steven Stahl.
Yes, sir. Yes, sir. So I have, I really have three questions. One's a super simple softball. One is a little bit more difficult, and then the last one is a two-parter. So my first question is the super easy one. You stated that you have flight altitude capabilities up to 200 feet, but your website only sells a 50-foot tether, and it doesn't show us that it's an interlinkable tether. It's just a 50-foot tether. So if I'm a customer and I'm buying one of your products, am I buying a package? And what's the 50-foot tether for if I want the option to go up to 200 feet and y'all don't sell that?
Hey, Steve. I think that might be a misprint or kind of maybe the wrong data. The tether is actually 245 feet long on the system, and the 45 feet is really just extra baked in there for wind and as the tether gets bowed out from the wind and elements. So all the systems actually come with 245 feet on the reel.
Okay. All right. That makes sense. I'll send you the link just so you have that. So you can see what I'm talking about. Maybe I'm trying to. The second question was, With y'all being a tethered system, a tethered platform, it's not letting me send this message, but I'll work it out. With y'all being a tethered platform up to this point or at all, has the FAA Advanced Aviation Advisory Council had any influence on your operations whatsoever?
No, it's a good question. Up until now, no. We've been treated just like any other free flying system, just really like any other drone. The tethered space is so small at this point that there's not really a lot of push to get that changed. Now, I will say there are people that we're working with and are working to help us to lobby some potential changes to the rule set for tethered drones. But for now, it's an aircraft like anything else. So
okay. Okay. And now my final question is really a two-parter. You had talked about real-time viewing. You had talked about it on your first couple of slides. This is mounted to this autonomous ground vehicle. This is mounted to a Abrams tank or Bradley, whichever one it was. And you were talking about what I perceive to be real-time viewing operations. Do y'all also, what type of metrics are y'all normally reserving, or is that client-based? I mean, do y'all have a platform that is, these are the normal metrics we do other than just flight data,
Yeah, it's very much client-based. So typically the application will also come with the new client and a new project. So in the case of the Bradley, for example, it was very much to be used as a periscope. And so all they really cared about was the video feed from the electro-optical camera or the infrared camera and being able to zoom in on a target long distance. They don't care about anything other than that. Well, then after we give it to them, all of a sudden it's, well, can we target with this? Can we get coordinates off of this? Can we figure out where that person's at? Well, okay, yeah, let's work with you and figure out how we do that. In another case, doing the same type of integration, mounting it onto a large vehicle like that. They don't want anything to do with the camera. They just want to stick a radio on it. Whether it's a node for another network or a potential, like a bridge between two locations or two vehicle groups, they don't even want to see a video feed. So really, client by client, it's completely different use case and what we try to provide for them.
Awesome. Thank you so much. I appreciate your time. Thanks for meeting with us today.
Sure thing.
PJ?
Good evening. My question is, what is the purpose and the advantages of having a tethered UAS as opposed to an untethered UAS?
That's a great question. So let me tell you why tethered UAS are the best. No. So tethered UAS are very useful for a particular set of things. They can stay up in one place for an extremely long time. This, for example, if I'm patrolling a perimeter of let's say I have a base or a building or something I want to guard, I can throw this thing up in the air and have constant surveillance, just like a security camera, at an altitude that allows me to see things very far away 24/7. With a free flying drone, I don't get that capability, but I do get the versatility to go out and, let's say, interrogate a target or identify a person more in depth. So one of the main advantages is persistence, being able to stay in one place for very long. And the second, that's a little less apparent, is the ability to keep the communications completely secure. With a free flying drone, you have RF signals going to it. You have to communicate with it from a distance. So you send a signal. That signal can be picked up on and someone can identify where you are, who you are, jam your signal, crash your aircraft. With a tethered drone, can't do that. We've been hit with, all kinds of stuff, and the system, it doesn't get affected by it. So those are kind of two main points I could think of.
Okay, thank you.
Lori.
Thank you. Oops. Oh, I wasn't muted all the time. Sorry. Thank you. All right. So I had a question. It seems by what you've done in the presentation that most of your direction has been military related or possibly law enforcement or security. I was curious, on a prior class we did some research, and I had come across an Israeli startup, Tethered, TVEL, who has tethered drones actually for picking fruit in a fruit orchard. So I was wondering if indeed, do you specialize in a certain area, or do you have other applications for your tethered drones at this time?
Yeah, good question. One of the limitations of what we're able to do, being kind of a small company, I'd say, is bandwidth. What I would say is bandwidth. The ability to engineer different solutions and come up with new ideas. So something we decided quite a while ago was really to focus in on just one thing and try to do it right. So right now we focus really heavily on, DoD, government, and whether it's surveillance or communications, those tend to be the two kind of main food groups right now. Now we're branching out into more commercial aspects for security purposes and different things like that. But primarily, those are the use cases, just limited manpower.
Understood. I was just curious if there was something more. And I'll tell you the truth, the idea of secure communications, I would imagine that's a major difference, especially with the military. It's one of the issues we've addressed several times. And I think it's a really interesting point. Thank you again.
Sure thing.
Thank you, Lori. Matt.
Hey, good evening. Two quick questions, and maybe relatively simple. And the first one is, what's the significance of the 200-foot range on the tether? And why wouldn't you guys expand that at all? And then the second one is, even if you're able to discuss, is there any R&D? Are you guys able to weaponize the drone out in the field?
Yeah, it's good stuff. So the 200 feet is a very much an engineering problem. So if you can imagine, I have to contain 200 feet of a cable wrapped around inside of a box that's going to be in the desert or in the Arctic somewhere. And I got to keep it either cool so it can continue to function and not overheat while it's passing all this power through it. If you ever just take a coil and wrap it around your finger, run electricity through it, you're going to notice it's going to get hot. So one, it's limiting the amount of heat that's being generated inside the tether kit so that it continues to operate. If you wrap too much tether on there, generate more heat, more resistance, that kind of thing. Another is the efficiency loss over distance. As I'm transmitting electricity from the ground to the air, there are losses over the cable. So I'm going to suffer some level of efficiency loss, which translates to heat mostly. And that is going to cost me power on the ground. Some of these people like to be lightweight. They want to operate with a tiny generator instead of a big honking one. So you got to be able to bridge that gap. Another thing is payload. As a tethered drone, really all we're bringing to the table is the ability to carry a payload to an altitude. The drone is essentially a work truck, and you just put something on it and then you take it up. Well, if I have to also carry this cable, the more cable I put on it, the less payload I can take because I have to account for the weight of the cable. So you have to find a sweet spot in altitude that allows you to carry the payload you want to achieve the goals you're trying to do, but also not go too high to where I'm limiting my capability. And really, what am I gaining between 200 and 300 feet anyways? I'm already up there. And then finally, it's wind. So if you can imagine a cable in the wind, it doesn't sound like a lot of air resistance, but when you got 30-mile-an-hour winds coming and this thing's trying to stay in place, and there's 200 feet of surface area while thin, it definitely has an effect on the aircraft. So that is, you kind of take all those things together and you find a sweet spot in the middle. And we ended up at 200 feet. I'm sure there are other good ideas, but that seemed like a perfect spot for us. And your second question, if you could just remind me.
Yeah, it's just about the ability to weaponize the vehicle tethered to the base.
Yeah, so the vehicle itself, I don't think the concepts ever come up. There are things that people want, such as like a laser designator or the ability to get grid coordinates for a potential target or something like that. It's very much a way to keep some distance, but putting any sort of live munition or weaponizing the drone itself in a kinetic way has never come up in discussions. And just real quick to address the link that Steve sent out earlier. That cable that you're seeing there is actually the Ethernet cable to the base station. So you can connect it to your computer, not the tether itself.
Awesome. Thank you.
I don't know if that answered your question, Matt.
It absolutely did. Thank you very much.
Sure thing.
And then one of the students who's no longer in here had a question regarding if you are hiring field service representatives.
Yeah, I think, well, right now, I actually just hired someone from the Embry-Riddle Master's Program, one of the most recent guys I got. Not at this moment, but, you know, I can see a need for potential customer service soon. And really, if there's a point of contact that I can send any listings to, whether it's you, Brent, or anyone else, let me know, because if it ever comes up, I'll shoot it out right away.
Yeah, I'll introduce you to our career services folks that can definitely get you connected up.
Sure thing.
Buck has a question.
Hey, good afternoon. You were talking, and it seems like it's a pretty good system for surveillance, military-wise, being out in the field. I was just curious about what's the factor of weather for one of these drones? Like, how much could it be up there in the rain? What's the weather factor you're looking out for when you're designing this?
Yeah, so initially starting out, it was mainly about getting this thing off the ground and keeping it in the air. Once we got through that, it was these guys are going to fly it in any weather conditions. So we basically took mil standard 810G. It's like a 800-page document that tells you what to do, basically what are the standards, and I painstakingly read through that and tried to figure, we all did, and try to figure out how close can we get it. So what we designed to was being able to fly in the rain, fly in winds up to 30 miles per hour, fly in temperatures up to -20°C all the way up to 55°C, being able to sustain sand and dust and that kind of thing. And then easy to maintain. So being able to replace parts simply and all this stuff. The one thing we can't do is fly in the lightning. I really don't recommend it. You basically got a copper wire all the way up to 200 feet. I think you're just asking for it at that point. But yeah.
Thank you.
Mm-hmm.
Excellent. Any other questions? All right. Oh, Dan.
Yeah, I just wanted to caveat with what Buck was talking about. He basically was talking about environmental testing. And I was curious about that myself. How do you guys do that environmental testing? Because I had to take a tactical system down to Huntsville, Alabama, and go through the freeze and heat chamber. Mm-hmm. And that was interesting to learn how that's done. I was just curious. He brought up a good question, but it made me want to ask it myself too. How do you guys test your vehicle?
That's good. Yeah. So part of the design itself, or part of the engineering process, is to take these baby steps along the way to verify the design that we made. We have temperature chambers, we have rain chambers, we have the ability to put the system in dust environments and really exercise it in a controlled way. We also have an EMI chamber. One of the things that maybe doesn't get thought about in the UAS world is radiated emissions. So your motors, your ESCs, electronics, they all generate signals, and those can really disrupt payloads. Our system is completely designed around being radio silent. So we take a system into a tent, we run it up, and they're able to take measurements on a spectrum analyzer and identify it. Thermal chamber, we're able to run it there for hours and days, max and min temperatures, find out what's breaking, what's working. And then at the end of all that, we hand it over to a soldier, and by golly, they find out what we messed up. So, there's always something that we didn't figure out or another problem to engineer. And I think it's a great thing, actually, because the more feedback you get, the better it turns out to be. So, and plus it ends up flying in all kinds of various environmental situations. You get people out in the desert, you get, that's a completely different environment than, say, the mountains, and a completely different set of problems.
Excellent. Well, on that note, I want to thank everybody for joining us tonight, as well as a huge thank you to Michael for sharing his perspective and his thoughts regarding this exciting technology. It's been a very informative and enlightening session, and it helps us to better understand the future of this field. As a reminder, I am going to stay on for a little bit to answer any questions you might have regarding assignments or activities, or if you just want to chat regarding UNSY 603 or ASCII 693. The recording of this should be available by tomorrow morning. So with that, everybody have a great evening, and thank you again, Michael, for visiting with us.
My pleasure. Thank you for having me, and hope you guys all have a great night, and talk to you guys another time. Bye.
TJ, you said you're in UNSY 410. Is that through Dr. Clanky?
That is correct.
Yeah, I'll send it over to him most likely in the morning.
Okay, I appreciate it.